In this video, we're taking a look at algorithms. The word algorithm is based on this Persian gentleman's name, who lived in Baghdad from approximately 780 to 850 AD. He became famous because of his systematic and logical approach of mathematical problems. Because he did this in a step-by-step manner, he's also called the father of programming. This step-by-step thinking is used in all technology. We split up complex problems in different little simple steps. Like tying your shoelaces. For humans, that's one instruction. Tie your laces. But if we want a robot to do that for us, he will not understand that same instruction. So in order for this robot to understand what he has to do, he will split up the instruction in little simple parts. Every single part is called a command. Have a look at this game. The two commands we will be using are the right arrow to move right and the to button to jump. We can help the duck jump over the block. You see that we have to give one command at a time. Now in a game, of course, that's fun, that's the point of the game. But if we want the robot to tie our laces, giving step-by-step commands is totally inefficient. That's why we use functions. Functions are combinations of commands that are being programmed beforehand and can be activated with a single push of a button. So you push a button and a whole series of commands will start. Now this function right here makes sure the duck keeps on moving to the right and jumps when necessary to reach the end of the screen. A function can be made up out of different parts: sequences, loops, and choices. A sequence, as the name suggests, is a sequence of commands. Each command is programmed individually and stored. In this case, the sequence is activated using the Go button. You can see this sequence's different commands here. It gets the job done, but it will not win a beauty contest. And it's a lot of work, especially when dealing with longer sequences. You have to manually program each simple step. A solution to that problem is the loop, also called a for loop. In a loop, sequences are repeated, or looped, for a number of times without having to program them all over again. Look at what happens in our game. The loop is go to the right, go to the right again, and jump to the right. These three commands are looped 3 times. Of course, this only works here because the blocks are the same distance apart. If that isn't the case, we have to build in a choice. Choice is always a binary thing. We ask a yes or no question, often combined with a loop. That's what happens in this game when we start the algorithm. With each step, the duck asks himself the same question. Is there a block in front of me? The answer is binary, it's yes or no. If it's yes, the duck has to jump to the right. If it's no, the duck has to move to the right. This choice will be looped, for example 10 times. This algorithm is very efficient. Our duck can keep moving through a lot of levels with just this small algorithm. But sometimes things go wrong. When that happens, we have to debug. That means we'll be looking for programming errors, so-called bugs. To do that, we have to analyze what went wrong, where it went wrong, and then fix it. In this algorithm, for instance, there is a bug. It's what we call an infinite loop. The duck will keep on jumping until the end of days. So what's the problem? The duck moved to the right as it should. That means that our question is fine, as is the command following the no option. The problem is situated in the yes option. The duck jumps, but it doesn't jump to the right, it just jumps up. So when it sees a block, it jumps up. And when it lands, it's still in front of a block. So it jumps again, and again, and again. So that's what we'll have to adapt. A quick recap. An algorithm is a step-by-step analysis to solve a problem. Common words you'll always hear in this context are a command, one single instruction, a function, a collection of commands in order to automate something, and functions can contain the following: a sequence, an order of commands each following the other, a loop, or a repetition of commands, and a choice, commands depending on the outcome of a yes or no question. Sometimes things go wrong. In that case, we will debug, and that's very normal. A programmer's work is 10% thinking out algorithms and 90% debugging. Now that you know the basis, you're ready to get started in the next videos on algorithmic thinking, in which we will really start programming.